We'll proceed in algebra, vector algebra and calculus. Vector, you are amazing. But how vector you are amazing that we have not seen. So the enjoyment of anything, it is called 1% of enjoyment when we see it. When we know about something new like vector, the first impression what we get is what we see. And the biggest impression we get when we get through its nature. What is its nature? How it is useful? How it would help? The external appearance is 1% and internal appearance is 99%. So how vector is useful? From the external appearance, it looks like vector is energy which has a direction. Energy which has a direction. Certainly, it has magnitude. A direction and magnitude constitute a vector. What about algebra, which has a magnitude? That is algebra, which has a magnitude, no direction. But the vector has direction and magnitude. That is vector. What is the salient feature of a vector? Vector is nothing but the addition of different orthogonal components. This is how vector is represented. Okay, so vector has direction only along the orthogonal components. What are you talking about? Okay, I have orthogonal components at x and y. Okay, you have x and y. X axis is represented as I unit vector. Y axis is represented as j unit vector. Okay, any vector in xy plane is combination of these two vectors. What are you talking about? Okay, I have an energy vector that is 5I. 5 is the strength and direction is I. I have energy vector that is 10J. Magnitude is 10 and direction is J. If I say I have a vector 5I plus 10J, 5I plus 10J, it's possible. There is a new vector called 5I plus 10J. So if I have xy plane from origin, I can draw line from origin. If this is the origin, this is x-axis, this is y-axis, this is xy plane. From origin, I am drawing line along all the direction. How many line I can draw from origin in 360 degree? Infinite. I can draw infinite lines. Every line is a vector. Every line is a vector which has a direction with theta angle from x-axis and which has a magnitude. Very true. Okay, if that is the case, then how I can represent all the vector? All the vector would be represented in term of x and y only. Okay, I have a vector called I. I have a vector called I plus 0.5j. I have a vector called I plus j. I have a vector called I plus 2j. I have a vector called I plus 5j. I have a vector called j. Understandable, right? The vector is from x-axis, it is moving like this. So many vector I have. But if you see closely, all the vectors are represented in x and y only, in I and j only. So if I say I have a vector called I plus 5j, I have a vector called I plus 5j. This is x-axis, this is y-axis, this is x-axis, I plus 5j. Then on x-axis I have a distance 1. On y-axis I have a distance 5. This is a point called 1 comma 5. If I draw a line from origin to 1 comma 5, this is the vector. What is the direction of the vector? The direction of the vector is whatever angle I am making with the x-axis. That is the from x-axis. That is the direction of the vector. If it the vector I plus 5j makes angle theta with the x-axis, then direction of the vector is theta equal to tan inverse 5 by 1. Tan inverse 5 is the Angle with that is the direction of the vector. What is the magnitude of the vector? I plus 5j. Magnitude of the vector is 1 square plus 5 square root. Okay, so this is the fundamental of vector. Any vector, there can be infinite position vector. Position vector means a vector that begins from origin, it goes till the strength of the vector wherever it goes till that point. That is called position vector. In xy plane itself, along x-axis, how many vectors are possible? If you talk about direction, then there is only one vector is possible. If unique direction, then only one vector is possible, that is I. If you talk about combination of magnitude, if you see the combination of magnitude and direction together, then infinite number of vectors are possible along the x-axis only. I, 2i, 3i, 2.5i, zero point 0.5i, so many. Direction is same. Direction is same. What is the direction? Unit vector is called direction. If I have zero point 0.5i, then zero point 0.5 divided by zero point 0.5, I is the direction of vector. So all vector along x-axis with different magnitude, they would come in direction of I only. If I have a vector I plus 5j, then what is the magnitude of the vector? 1 square plus 5 square root. What is that? What is the direction of the vector? What is the unit vector? Then unit vector means a vector without any magnitude. Then I plus 5j divided by square root of 1 square plus 5 square. That is the unit vector. Unit vector which has a strength of 1. Okay, now too much theory, too much fundamentals done. Now, question arises is what is the length of a curve? This is where we are now hanging around. What is the length of a curve? If this is the curve, what is its length? What is the parameter length of this curve? This is one question. What is the parameter length of this curve? If that is true, what is the parameter length of this curve? Then this is, what is this? What is this? Looks like I have seen this. Many book, this is, what is this? Hup, hup, hup. This is x-axis. This is x-axis. What is this line? Can you see? Low, then going down and coming up. This is sinusoidal wave, where at the origin the height is 0. Then height is growing. When x-axis is pi by 2, the height is maximum. Then height is coming down. When x is pi, the height is 0. When x is growing, when x is 3 pi by 2, then height is minus 1. And then when x is 2 pi, then height is 0. If I talk about angular fashion, then when angle is 0, then height is 0. When angle is 90 degree, this is x-axis, from x-axis angle is 90 degree, then height is maximum. It can be seen. When from the x-axis we are calculating the height. When this angle from the x-axis, when the angle is pi, then height is 0. It is on x-axis only. When angle is 3 pi by 2, then height is minus 1. When angle is 2 pi or 0, then height is back to 0. This is called sinusoidal wave. Okay, so I mean this is the kind of typical sinusoidal wave I showed in angular fashion, but it worked, right? In a circular fashion, I showed it and it worked. I never thought I'm showing in circular fashion. Okay, at the angle 0, sine is 0, and angle pi by 2, sine is sine is 1. Actually, this height is radius of the circle, not 1. Okay, but we are saying it is 1. Why we are saying it is 1 is sine is nothing but perpendicular by hypotenuse. So perpendicular height is 0, so sine is 0. If perpendicular height is a, that is radius of the circle, then the a by a, 1. Here again height is 0, 0. Here height is minus a. Here when angle is 3 pi by 2, then height by hypotenuse. Then height is minus a. Hypotenuse is a. Height square by base square is hypotenuse. So base here, if I talk about here, okay, then hypotenuse is radius is a. Means hypotenuse is base square by height square square root. So it cannot be negative. So hypotenuse is positive, whereas height is negative. So this is minus 1 and back 0. So nicely we showed the sine wave in circle only as far as angle is concerned. Now, if I am asking what if this is sine wave, if this is sine wave, what is the length of this curve? Can someone tell me? What is the length of this curve if it is a sine wave? From 0 to 2 pi, what is the length of this curve? From 0 to pi by 2, what is the length of the curve? From pi by 2 to pi, what is the length of the curve? From pi to 2 pi, what is the length of the curve? Can someone tell me? Not possible. Not even a single person in the world he can measure. I have something to measure. Okay, I have a scale. I believe I have a scale, and okay, I believe I had something to measure. Okay, so where it went, I also don't know. I used to have a scale that is also missing. Okay, so okay, not known, not yet. Okay, so idea is okay, consider this is a scale. Consider this is a scale. Through scale, can I measure the length of this curve? Not possible. Only possible is that if someone is drawing the sine wave, if someone is drawing the sine wave, I can put a thread and then I can measure the length. But that is error prone. Straight line I can measure. But curve line it is not possible. Curve can be a circular region. Curve can be a circular region. Curve can be a sinusoidal. Curve can be a parabolic. Okay, what is the length of the curve? That is a big question. Now, how I can find length of the curve? Okay, we will try to use vector. We will try to use vector. Now, to find the length of the curve, there are two ways in finding the length of the curve through vector. One is called primitive calculus. One is new calculus. New calculus means delta x and delta x tends to 0. Consider delta x and delta x tends to 0. This is new way of finding doing the calculus. Old way is through algebra. Just sit on top of algebra and then you try to find out the solution. That is the old way. We'll try old way and new way both. Now consider this is x-axis and consider there is a vector like this. This vector is I plus j. This vector is I plus j. What is the length of this vector? Of this this vector? What is the I'm sorry. There is a line that goes from 0 comma 0 till 1 comma 1. There is a line that goes from 0 comma 0 to 1 comma 1. What is the length of this line? This line, what is the equation of this line? That is y equal to x. This is the equation of the, okay, leave it. I believe I will not jump into algebra. What is the length of this line? 0 comma 0 to 1 comma 1. What is the vector representation of this line? Position vector. If 1 comma if 1 comma 1 is there, then position vector equation is I plus j. 1 comma 1. 1 minus 0I plus 1 minus 0j. I plus j. What is the strength of this vector I plus j? A square root of 2. A square root of 2 is the length of the line. There is a line. which is from 0, comma 0 to 1, comma 1. What is the length of this line? Try to find the vector. Vector represents the line, means it vector has two components, x-axis and y-axis. That's why it is I plus j. This is exactly we want. When we are trying to find the line length, when we are trying to find line length, then when we are trying to find line length, then we mix both the thing. Every point is represented at x comma y. In a line, every point is represented as x comma y. It has x component and y component. I need a part in mathematics that talks about both the components. That is vector. Only vector. If that is the case, then equation of vector is I plus j, where the x component is 1 and y component is 1. I plus j. If that is the case, then magnitude of the vector is length of the line. That is x square plus y square square root. A square root of 2. Square root of 2 is the length of your vector. Very true. What is the length of the vector that is connecting point 0, comma 0 to 2, comma 2? 0, comma 0 to 2, comma 2. What is the equation of this vector? That is 2i plus 2j. 2i plus 2j. What is the length of this vector? 2 square plus 2 square, square root. 4 plus 4, square root of 8 is the length of this vector. No, 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 no. Square root of 8 means 2, square root of 2. Square root of 8 is 2, square root of 2. Then you are multiplying by 2 to the square root of 2. Is it not true? If I have a vector that is from 0, comma 0 to 1, comma 1, the length is square root of 2. Now I am elongating this vector, I am making it double. If I am making it double, then what is the length of the vector? Double of a square root of 2. Can you see it? If I have a point that is 3, comma 3, then what is the length from origin to 3, comma 3? What is your length of the vector that is at 1, comma 1? That is square root of 2. 3 into a square root of 2. Much better than 3 square plus 3 square, a square root of 2. Not required. What it means, if I have a vector, if I get the vector length when x is 1, whatever comes, multiply by the x. That is the vector length. Can you prove it? Okay. Another is, consider I have a point that is 2, comma 5. I have a point 2, comma 5. What is the length from origin 2, comma 5 line connecting to it? Then its vector form is 2i plus 5j. 2i plus 5j. This is our way of calculating. This is primitive. We are approaching towards primitive calculus. Primitive calculus. Okay, so primitive calculus here, what is the length of the line from origin to 2, comma 5? What is the length of what is the vector equation when it is 1 in x-axis? Here it is 2 in x-axis. Then 2, comma 5 is 2i plus 5j. Then if I take 1 in along x-axis, then it becomes I plus 5 by 2j. I plus 5 by 2j. That is 1 if I take 1 along x-axis. What is the length of this vector? I plus 5 by 2j. That is 1 square plus 2.5 whole square, square root. Okay. Then what is the 1 square? That is 1 plus 2.5 whole square. What is 2.5 whole square? I believe it would be, I don't know, 5 by, sorry, 5 by 2 whole square. That will be 25 by 4. 25, 1 plus 25 by 4, a square root. That will be the length of this vector. If someone settled on the square root of 29 by 2, square root of 29 by 2. This is the length of the vector when x-axis along it is 1. Actually, the question was, what is the length of the vector from origin to point 2, comma 5? Multiply it by 2. Then it will become a square root of 29. Square root of 29. Same thing there also, right? 2 square plus 5 square, square root of 2, square root is square root of 29. So whenever I want to calculate the length of a line from one point to another point, then get the vector and then the vector equation when the x-axis is 1. If x-axis is 1, calculate the magnitude of the vector multiplied by the x. So if I say I am trying to find, consider I have a line, point, the point is x comma y, point is x comma y. Then what is the vector? That is xi plus yj is the equation of the vector line. Xi plus yj, where y can be anything. If I talk about line, then y can be x, 2x, xy2, something like that. Consider y is 8x, then xi plus 8xj. What is this length of the line? What is the vector equation when x is 1? Then it is I plus 8j. What is the length of that line? 1 square plus 8 square, square root. Square root of 65. The length of the line is x into a square root of 65. Makes sense, right? The square root means if I find a vector and try to get the x component 1 and get the magnitude of the vector multiplied by x, that is the length of the vector. That is the length of the line. Understandable, right? Consider I have a point called point. I have a point. You are talking about x-axis should be 1, right? I am giving point is 1 comma 1 comma x square. That is the point. 1 comma x square. 1 comma x. 1 comma x. Okay, if x is 10, then 1 comma 10. If x is 5, then 1 comma 5. That is the line. What is the length of the line? What is the equation of the vector? I plus xj. I plus xj. I plus xj. What is the magnitude of this line? 1 square plus x square, square root. 1 square plus x square, square root. That is the length of this line. 1. Okay. If 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 I that is the length of this line, but x is variable. Mind it, x is not constant, x is variable. 1 plus 1 plus x square divided by full square root. Okay, what would be the length of the line? X into square root of 1 plus x square. Not true. May not be true. Not true. What are you talking about? So consider the point is 1 comma x square. The point is 1 comma x square. Means if I talking about algebra, can you see the direction of vector is changing? If I say 1 plus xi, then if x is 1, the direction of vector is like this, where x is 1, y is 1, 1 plus xi. This it if at point this is point 1 comma 1. At that point, the direction of vector is like this. When x is 2, then it is 1 and y is 2. Direction is changing. Here it is 2. When x is 3, vector is changing. Depending upon x, vector is changing. Can you see? If I say I have a vector called 2 comma 5, it is fixed. If I have a vector 10 comma 15, then it is fixed. If I divide by 10, it becomes a vector, but direction is same. I make the vector length smaller. If I have a vector called 10i plus 15j, 10i plus 15j, then I can say what is your vector when x-axis is 1? Then I plus 15 by 10j. Calculate the magnitude of this vector, multiply it by 10. Simple. Means I am facilitating the calculation only. Because if I divide a vector by a constant, vector direction is not changing. Only magnitude is changing. And magnitude is the length of the line. Now, if I have a line that is x, uh, if I have a line connecting a point called 0, 0 and 1 comma x, where x is variable, what is length of the line? What is the, it is the length of the line. X is 1, x component is 1, right? So length of the line is 1 square plus x square square root. True. Okay. What is the length of the line? What is the length of the line when along the x, if I take x amount, if I take x amount. So consider the point I am talking about is x comma x square. This is the better question. The point I am talking about is x comma x square, x comma y equal to x square, x comma y x square. Then line connecting to it is from the origin. The position vector is xi plus x square j. If I'm talking about that x, the length along the x-axis should be 1, then I divide it by x, I plus xj. Okay, then at any x, what would be its length? Multiply by x or square root or something like that. Okay, it looks little clumsy, right? Okay, better we will take another example. Now consider I have a circuit. We are talking about primitive calculus. We are talking about primitive calculus. Okay, so whatever we have learned till now that if I have a vector, if I have a vector and if I calculate the magnitude of the vector and a vector represent a line, quickly I can get the line quickly I can get the length of the line. If someone is saying that I have a line connecting these 2 points, then I can represent it as a vector, numeric vector, not algebraic vector. Numeric vector. We are jumping into algebraic vector where things are variable so that we can apply calculus over it, because at the end we are trying to calculate the length of an arc. It is not a straight line. There is a problem. And length of the arc, things are algebraic in a way. Every moment things are changing. It is not a straight line. It is not linear. If it is linear, calculate the magnitude of the vector. That is the length of the line. This is what perfectly we saw. Now consider a circle. Circle, any point can be represented as x comma y. Any point can be represented as x comma y. If I represent any point at x comma y, then position vector from the origin to the x comma y is xi plus yj. If, if it is xi plus yj, it is xi plus yj. How to calculate the vector that is tangential? If we want to calculate, if we want to calculate the length of the curve, then I need a vector that is along the curve. Session by session it will be clear. Right now it may look little bit difficult. Okay, so if I have a position vector, it is perpendicular to the curve every moment. So this position vector is not representing the curve. Okay, consider this is the line, this is the line, and here is the origin. If I draw position vector at any point, this position vector is not representing the line. Perfect, right? The vector which is representing the line is the vector that is parallel to this line. This vector is representing the line. If line is not passing through the origin, if line like x plus y equal to 3, if this is the x-axis, this is the y-axis, then x plus y equal to 3 is this line. This is the origin. If I draw position vector at any point on the line, that is x comma y, that is xi plus yj. So if this is the line, then at any point from origin, this position vector, certainly it is not representing the line. The vector which is parallel to this line is representing this line. So that is the concept. Okay. If that is the concept, if I get a vector that is exactly perpendicular, exactly parallel to this line, then from this point, from this point to this point, if I get the vector, calculating its magnitude would give the length. Its magnitude would give the length. Okay, we will try it now. But before trying, let's see it. Okay, like if I want the length of this arc, then if I from origin, if I go with the position vector, this position vector is perpendicular to the arc every moment. It is not representing the arc. The vector that is representing the arc at any moment, since it is a arc, it is not a straight line. At any moment, the tangent vector, it is representing the arc. Okay, tangent. What? How to get tangent vector at any point? Tangent vector at any point. What is the equation of this curve is? That is xi plus yj position vector is. If I differentiate it, then it becomes I plus dy by dxj. Y is square root of a square minus x square as far as circle is concerned. That becomes minus xy square root of a square minus x square j. If I do dot product of these two, I xi plus yj with I minus xy because square root of a square minus become y only. If I do dot product of these two, xi plus yj and I minus xyj, it will become x x into minus x, it becomes 0. Means if I for any arc, any position vector, if I do if I calculate the its derivative, it's become a tangential vector because it is perpendicular to it. Okay, to calculate the tangential vector or to calculate the vector that is along the curve line is position vector. You derive it, you calculate the derivative, then you get the vector along the line. I mean, I can prove it. So now consider I have a x-axis and I have y-axis. X-axis and y-axis. Now there is a line called x plus y equal to 3. Means it is making intersection on x-axis at 3 comma 0, on y-axis at 0 comma 3. 0 3 0 0 comma 3. There is a line called x plus y equal to 3. What is the length of the line from intersection on x-axis and intersection on y-axis and x-axis? What is the length of this line? Here the intersection is 3 comma 0. Here intersection is 0 comma 3. What is the length of this straight line? Okay, if this is a straight line, then at any point can be represented as x comma y. If that is true, then this is the position vector of any point from the origin. Then it is xi plus yj. If I calculate derivative of it, then it will be tangential to the line. What is tangential to the line? If this is x-axis and this is y-axis, and if this is x-axis, this is y-axis, and this is the line, and this is the okay, this is the line, and this is position vector from the origin to the line. This is the line. This is the position vector. One is position vector, one is the line at any point x comma y. For this position vector, if I calculate the derivative, it will result in another vector that will be tangential at this point. It will be tangential to this line, perpendicular to this line, or tangential at that moment. Tangent to this line is along this line only. Tangent to this curve is like this, along the curve. Tangent to this straight line will be along the line. This is what we want. Vector representation of any line is nothing but tangent at that point. So if that point is xi plus yj, then if I calculate derivative of it, it will result in another vector. That is nothing but the vector of the line. This is another invention, how to calculate the vector equation of the line. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number, plus 91 is the India country code. Please do support, it helps us. Anyway, so I'm trying to calculate the length of the line from the x-axis and y-axis. The line equation is x plus y equal to 3. Now, what is the representation of this line as vector? That is, if I take any position vector x comma y, do the derivative that will be tangential at that point, and then we will get the vector equation. So, xi plus yj, that is I plus dy by dx j. That is the equation of the vector along the line. I plus dy by dx j. I plus dy by dx j. That is the equation of the vector along this line. What is y? X plus y equal to 3. Y equal to 3 minus x. So I plus 3 minus x by dx minus I, j. I minus j is the equation of that line. If that is true, then I is unit. This is what I was talking. I is unit. There is nothing along the I, 5i, 6i, 7i. If it was there, then I have to divide it by that so that it will be, I will be unit. So I minus j, perfectly. Now, what is the length of this vector? I minus j. What is length of this vector? Then when length of the vector is square root of 2. Length of this vector is square root of 2. If it is a square root of 2, then multiply by x. Along x-axis, you will get the length of this vector. Multiplication, if I am talking about this, if it is, there is no algebra here, right? I minus j, there is no algebra here, pure numeric. So I can simply multiply by the length in x, that is 0 to 3. 3 into a square root of 2 is the length of this line. Perfect, right? But consider this is algebra. Consider this is algebra. Consider the net vector at any moment is I minus xj. I minus xj. If that is the case, then what is its magnitude? That is 1 square plus x square square root. That is the magnitude. What is its length? For 0, now I calculated 0, 0 to 3. 0 to x, what would be its length? 0 to 3 is the net limit. What about any x? Then it will be 1 square plus x square square root into x. Wrong. This is what is the primitive calculus. When we are trying to do multiplication of two items in algebra, our main idea is to calculate the to calculate the area of it. How you can say like that? Okay, if I say I'm multiplying 3 into x, I'm multiplying 3 into x, it is as good as if I draw a area. I'm not saying rectangle. If I draw an area, multiplication of two items in mathematics is as good as if I take a rectangle and it is of two sides. If I take a rectangle and if I draw two sides with the length, what is the multiplication of 3 into 5? Multiplication of 3 into 5 is, if I have a rectangle, one side is 3, other side is 5, just calculate the area. Okay, calculating the area means 3 into 5 only, right? Same thing. No, calculating the area is not multiplication. That is the catch here. What is 3 into 5? If you take a rectangle, one side is 5, one side is 3, then area of the rectangle is the multiplication of 3 into 5. Area of rectangle is 3 into 5. No, area of rectangle is not 3 into 5. Area of any rectangle is, you take a square of size 1 into 1. Take a square of size 1 into 1 and place in the rectangle. If this is a rectangle, if this is a rectangle, take a square of size 1 into 1 and place it here. Place it here. Place it here. It should fit the rectangle. Count it. How many are there? That is the area of the rectangle. It is not multiplication. Completely not. So, if I get the area of a rectangle, one side is 3 and one side is 5, that is the multiplication. If that is true, then what is the area of what is x into x? What is x into x? X into x is nothing but what is x. Consider that I am trying to multiply two items. One is x. Now we are entering into different world. One is x. One is x. One is x, and another is x. In algebra, it is changing. If I say one is x, another is 5, then what is the area? Area, if you calculate 111 square, it will be as good as 5 into x. 1 is x and 1 is x. Can you see? One is variable x, another is also variable x. If that is the case, then it is not rectangle. It is a triangle. What is the area? X square. Completely wrong. If one side is x and other side is a constant, what is the area of this shape? That is x into 5. One side is x, another side is x. That is a triangle. What is the area? X square. Wrong. That is not x square. That is x square by 2. One side is x, another side is x, another side is x square. One side is x, one side is x, another side is x square. What is the area of the shape underneath it? X into x square. Wrong. It is x to the power 3 by 3. So if we try to find the multiplication of any algebra, then as per the fundamental of mathematics, if I multiplying two items, then draw the area, and whatever the area comes in, that is the multiplication. So in this kind of terminology where things are changing, one is independent and one is dependent. When we are talking about the length of the line and vector form, then I then vector form is xi plus yj, where y is dependent upon x. Y is not independent. If two entities are independent to each other, then we can multiply. If they are dependent to each other, we cannot multiply in algebra, because algebra multiplication is same as calculating the area of the shape, and area is not rectangular when it comes full-fledged algebra. Then to find the area, rather than multiplying these two items, we have to go for integral calculus. Then only we will get the area. Then only we really get the. Then we will really get the multiplication. Okay. So now we are in phase of trying to calculate the length of the line that is straight, length of the line that is straight. Then the first try to find the vector of this line. When you get the vector, then multiplied by x, that is from 0 to x, that strip of the line, that much will be the length. But that length, so calculate the vector, get the magnitude of it, and then multiply by x, that will be the length of this vector. But it has to, the magnitude has to be constant. If in the magnitude, if there is any variable out there, then direct multiplication would not work. What are you talking about? Consider that there is a line, there is a curve called x square. The equation of the curve is y equal to x square. This is typical y equal to x square is the curve. Actually, the equation of the curve is y minus x square equal to 0. Y minus x square equal to 0, or y equal to x square plus 4. Now same curve, if I lift 4 along the y-axis, this is the equation of curve, that is y equal to x square plus 4. Y equal to x square. Now it begins from origin. Y equal to x square plus 4. Now what is the vector representation of this curve? Not possible vector representation. What is the position vector of this curve? Okay, at any moment of this curve, any moment that is x comma y, at that point I can calculate the position vector x comma y. What is that? That is xi plus yj. What is that? That is xi plus x square j. This position vector will keep on changing when x is changing. Now we are entering into algebra now, algebraic vector. Xi plus yj, xi plus x square j, it will keep on changing. Can you tell me the tangent at any point? Now, because tangent is changing all along. For line, what we calculated, tangent was along the line. But here, tangent will be along the line at that moment. Every moment, tangent would change. This is primitive calculus. What is the tangent at that moment? You tell me. It is xi plus yj, same as I plus dy by dxj. That is I plus dy by dx is 2xj. So at any moment, the vector equation of that point, vector equation of that line at that point, every moment in the line vector equation is changing. Every moment vector equation is changing. If it is a straight line, then every moment vector equation is same along the line. But every moment, if line is a curve, every moment vector equation is changing. If that is the case, then what is the vector equation at any point x comma y? Then it is I dy by dx means I plus dy by dxj, I plus 2xj. Now, can you calculate the length of this curve from 0 to x? 0 to x. Then first try to calculate the magnitude of this vector. That is I plus 2xj, 1 square plus 2x whole square, square root. 1 plus 4x square root is the magnitude of this vector. Which vector? The curve vector. There is a curve vector and there is a position vector. Position vector is different. If I differentiated the position vector, it became the curve vector at any moment. At any moment, the magnitude of the curve moment. This is algebra. This is primitive calculus. At any moment, what is the curve length? Any moment, what is the curve length? Any moment curve length, not from the origin we are talking. Momentary curve length. Momentary curve length at any moment is square root of 1 square plus 4x square. What is the length of this curve any moment? Okay, what is the length of this curve from 0 to x? What is the full length of the curve? If I say, as per the fundamental we saw in the previous cases, if I have the length of a vector when x is 1, just multiply by x, you get the full length. Like we were calculating the length of the curve from 0, 0 to 2, comma 5. The vector is 2i plus 5j. That is same as I plus 5 by 2j. Whatever the magnitude comes, multiply by 2. What is the length of the vector when x is x, not 2? Then that is 1 square plus 5 by 2 whole square, whatever comes into x. Same thing will apply here. This is called pseudo multiplication. Pseudo multiplication, not original, abstract multiplication. So if I have a momentary vector equation, that is x vector equation, that is I plus dy by dxj, then momentary, the length of the vector is 1 plus 4x square root. What is the momentary length of the vector when on x axis the length is 0 to x? The momentary length is the square root of 1 plus 4x square into x. Okay, momentary length is x, but when multiplication of algebra comes, then it leads towards the area calculation. When it comes to area calculation, then it is integral calculus. Now, rather than saying a square root of 1 plus 4x square into x will give the length of the vector dx. This is primitive calculus. Dx, the length of the vector into dx. If the length of the vector is constant, then just multiply by x. All right. Just multiply by x will give the multiplication through area calculation. Area calculation and multiplication are same when one side is at least one side is constant. But multiplication and area calculation is not same when both sides are algebra. Like like we say that 3 into x is same as, if I have a one side as 3 and one side as x of rectangle, the area is 3 into x. But one side is x and one side is x, then area of that shape, it is not a rectangle. The area or multiplication is not x into x. It is integration of x into dx. Similarly, if I have a vector that is I plus 2xj, where ith component is 1, this is what we wanted. Calculate the magnitude, that is 1 plus 4x square root. Then what is the length of this from 0 to x into x? Not true. I can just abstract fraction, I can say x, because this side is algebra Algebra, if I want the multiplication through multiplication, then we have to go by the area calculation, integral calculation. Then it becomes a square root of 1 plus 4x square into dx. Integrate it from 0 to x. This is the proper way of doing the algebraic multiplication. Someone can calculate, right? I don't know. The square root of 1 plus 4x square dx from 0 to x. Okay, I believe in the case of or someone can try sinusoidal. Okay, so if y equal to sin x, then it is 1 plus dy by dxj. Then 1 plus cos xj. Magnitude is 1 plus cos square x square root dx. X is from 0 to pi by 2 will give the exact length. I don't know what is 1 plus cos square x square root dx. We try for the circle. Okay, that is I plus dy by dxj. I plus dy by dx is minus x by square root of a square minus x square j. The magnitude would come as a by square root of a square minus x square. 1 square plus x square by square root of a square minus x. 1 square plus x square by a square minus x square root dx, that will come as a by square root of a square minus x square dx. From, if I'm trying to find from here to here, 1/4 of this, then it is 0 to pi. 0 to pi by 2. 0 to pi by 2. So 0 to pi by 2, then a by square root of a square minus x square dx. Okay, that will come as the net length. If that is the case, then a by square root of a square minus x square. A I can keep outside. 1 by square root of a square minus x square integration is sine inverse x by a. Well, if I set 0, then it becomes 0. If I set a, then it becomes pi by 2. The net length is, I believe, pi by 2 by a. Pi by 2 into a, that is 1/4. Multiply by 4. 2 pi a is the length of this circle. We were lucky that we could integrate it. Otherwise, someone can try square root of 1 plus square root of 1 plus cos square x dx and 0 to pi by 2 to get the length of sinusoidal curve from 0 to pi by 2. Okay, this is primitive calculus. Primitive calculus means try to find everything in algebraic terms. There is no delta x tends to, we never consider delta x, consider delta x. We will do that also. Consider delta x. And delta x tends to 0. Then this becomes 0, this becomes 1. This is the new way of calculus. Old way is that try to find out as a variation of algebra only. This is what we did. We started with the numeric vector and tried to calculate its length by multiplying it by x. And then we tried with the curve, get the length of that curve vector at any point and again multiply with the x. But since curve length is coming in algebra, we cannot directly multiply with the x. It will become dx. And that is the way we calculate the multiplication or multiplication through the area of the curve. This is primitive way of calculating the curve length. We will proceed and we will see new way in the calculus and we will do some exercise. Mind blowing, right? Please do support us. +91 is the India country code 94831 60610. 94831 60610 is the telephone number. +91 is the India country code.